can go, Joshua. You unmute. You unmute, Josh.
There we go. Okay. I hope I'm all audible now. Seems like it's recording. So yeah, I'm going to talk about the building of Veloren. I've got a cold and also a stutter, so I hope I'm going to be understandable. But if I'm not, I'm sorry about that. I'll try not to have a coughing fit. So yeah, a little introduction to the project. It's a free and open source game. It's built by its community, so it's very collaborative, even more collaborative than quite a lot of open source things. Quite a lot of software is open source in sort of a superficial way, but it's just worked on by one or two people, whereas Veloren's got a very large developer community now. It's an open world game, sort of similar to Breath of the Wild and Dwarf Fortress in terms of the simulation aspects and the details and complexities of the world. And it's also multiplayer, so you can join with friends and go on the same world together. You can run around and explore and take on challenges and so on. So yeah, the big focus really is the procedural aspects. So the world is entirely procedural, which means that rather than it being authored by hand or modeled by hand, almost all of the elements in the world are generated through code, with sort of aspects of random number generation and other techniques and stuff like that. And of course, it's written in Rust. We've been using Rust for the entire length of the project. Almost all of the code base is in Rust. There is a little bit of GLSL and a few other bits here and there, but the large bulk of it, 95% or something like that, is Rust. So first I'm going to talk about the history of the project, and then after that I'm going to talk about some more of the technical stuff about what's actually going on inside. So the project started in 2018. As with all good things, it started as me procrastinating from my other responsibilities. I was doing my dissertation at the time, and I wanted something to distract myself, so I decided, hey, there's this game called Cube World, which hasn't had an update in 6 or 7 years, I think, at the time when I started. And I thought it would be nice if we sort of work towards an open source clone or fan-made remake of the game. So I posted a message on Reddit that is still up there and you can find it. And at the bottom of the message, there's something to the effect of, how hard can this be, really? Well, it turns out extremely hard. But the project quite quickly diverged from just being a simple clone. We realized that there were aspects of the original game that we didn't really like so much, or that we thought needed improvement, and we wanted to explore other ideas. So obviously it looks quite similar, but quite a few aspects of gameplay are different and stuff like that. And here was an old C++ demo that I built, which was pretty much my only prior attempt at building a voxel engine prior to working on this. So it was a bit of a stepping stone up, I think it's fair to say. So the initial development was fairly fast. It really occurred over a few weeks. We had maybe 30 to 40 odd people that were sort of really interested in the project and joined the Discord server. There was a lot of speculation, obviously, and maybe only about 10 of us that were actually sort of getting into the writing of code and looking at things. So we considered various alternatives: Unity, C++, D, which is a programming language which is sort of sits somewhere between C# and C++ in many respects, with other features too. But we decided to go for Rust, and as it was a low stakes project, it was just a fun thing we were doing in our spare time. We decided to go for it, even though it was quite a new language at that time. in 2018, there was substantially less of an ecosystem than there is now. Now we've got things like the Bevy game engine and lots and lots of crates that are built to handle all sorts of things. We've got WGPU and all of this stuff like that. And all of that didn't really exist back then, so it was a bit of a risk. As you can see, here are screenshots of the early stages of development, the first ever triangle that was rendered, the first cubes, and then finally a landscape with some extremely terrible specular lighting on there. So over the next few weeks / months, we built towards the first release, which was really quite a minimal thing. It was a bit of a bumpy release. It was the first time we'd done it, and the release effectively meant basically just giving people a link to an executable. Really, it wasn't much more advanced than that. The performance was absolutely abysmal. It was very, very poorly optimized. The game actually started in the command line, so you'd run the game and a terminal window would come up, and you'd have to type in the view distance you wanted. And there was absolutely no reference as to what the numbers were. So you typed in, say, 100, and you might have assumed it was in blocks, but actually it was in chunks, and then your computer crashed because that was far too many blocks. And for some reason that I don't recall, players could jump an enormous distance into the air. We spent so little time on sort of tweaking all the details that just random bizarre things happened like that. There were no animations at all, so every single character would do a bit of a Michael Jackson as you were moving along. And if you collided with a wall, you jumped right to the top of the wall. So if you went down into a cave, you had to be very careful, because if you ever touched the edges of the cave, you suddenly find yourself on the surface. Yeah, it wasn't great, but most importantly, it did exist, and it was multiplayer from the start. So the entire project has been built around multiplayer as like a very core feature. And so we had a few players, and you can see sort of people yelling about the existence of trees in the screenshot up here. It used to randomly choose your name, I think, and then you had to change your nickname with a command in the game. It was all very, very odd and terrible, terrible user interface and so on. So we realized after this that we needed to improve the user interface a little bit, because that text is awful. So we looked around and we didn't really find anything that we really liked back then. Nowadays we have the choice of things like iced, and there's various other UIs like EGUI and things like that. But excuse me one minute. So we decided to build our own, which in hindsight was a terrible idea. Because building GUI libraries is hard, and none of us had done it before. And it's even harder in Rust for very specific reasons associated with the way Rust forces you to think about ownerships that user interfaces often sort of try to completely ignore. And as you can see, it did the job, but it wasn't particularly great. It was very hard to use. There was no kind of consideration put towards things like accessibility or anything like that. And to be fair, that's still a thing we need to work on today. But there was a bit of a storm on the horizon. So if you're used to a more imperative and more object-oriented programming language, your way of writing code is probably to create some classes, and then you create some instances of those classes, so some objects, and then you have each of those objects sort of refer to each other, and you end up with basically an object graph where objects are referring to one another, and you rely on the garbage collector to pick up after you. But Rust is not really happy to go with this sort of design. It requires that if you want to mutate something, there's only a single thing that has access to that data that you're trying to mutate. So Rust provides a reference counting system where you can refer to something through a reference that is automatically handled. So when the last reference goes out of scope, the data itself will be dropped. So we instead started referring to objects in a referential way. But the problem with these reference counted objects is that they're immutable because they're shared between one another. So how do you solve that? Well, you put a read-write lock, which is basically a mutex. It basically means that all writes and reads to the object are synchronized with one another. So you can't have two things that are writing into it at the same time. The downside is that it's quite expensive. It was all over the code base. And every time you do that, it's either waiting for other threads or it's calling out to the OS in order to schedule new tasks and wait for the thing to be available. Excuse me. It's not great, really. And it's maybe all right if you're just using it for one very small thing. But this way of doing things was absolutely pervasive across the entire code base. It permeated everything. Every system, so that would be physics and rendering and so on, they all ran in their own thread, which means they're all waiting on each other for inputs, and inputs were being sent between the threads. So it was quite possible that if you were to click the mouse, for example, or move the keys, it would actually take a few frames for that input to make its way all the way through the system and finally get to the display in front of you. It was a very ad hoc approach to parallelism, which was not designed particularly well. And as I say here, it's basically an actor model, which is really, really good if you're trying to write if you're trying to write a web server, but it's not so great if you care about the latencies that are important in games. So about a year in development, we realized that this was becoming a little unsustainable. So me and the other primary maintainer at that point, XMac or Marcel, we kind of went back to the drawing board a bit. We started looking at videos and documentation about how existing game engines work and how they achieved what they did. And the conclusion we came to is that we needed a way of doing things that was more data-oriented. So we care less about the relationships between objects in the world and more about how that data is positioned in memory and how we access it and modify it and use it. So instead of having every system run in its own independent thread, we're going to treat the entire game as a pipeline. So every single tick, we'd run through all of the systems and we'd pass the game state through. Then at the end, we'd be ready to go around and do the next tick after the next frame had started. Instead of trying to refer to entities by referencing them in a rather direct way, we'd instead keep an ID that referred to that entity, and then we could look up the ID in a table for that entity as and when we needed it, which meant that we could be more careful about when we access things and when we forced Rust to accommodate for the fact that we could access things. We also went for a thread pool approach where we'd have lots of threads that run in the background, usually roughly one per core, and we give them tasks as and when they needed tasks, and then we receive the task back on a later date, usually a few frames into the future, and that allowed us to more effectively deal with the sort of latencies we see building up. The next thing was also to change how we stored data. So I mentioned that we went for a more data-oriented approach. And what this means is that rather than having objects in the world being an instance of a class, you'd instead have all of the attributes of those objects stored in a table for each attribute. So the usual approach of describing this is an array of structs type approach, and we went to a struct of arrays type approach. So we'd have one enormous array effectively for all of the positions of entities in the world, another array for all of the velocities, another array for all of the descriptions of the bodies of those entities, so what they look like, things like that. So yeah, it was time for a rewrite, armed with this new knowledge. So this was I think Christmas 2019, pretty much on the day, or rather the day after. I'm not that sad. I don't write code on Christmas. That I decided I'd have a go at trying to rewrite things from scratch, and it was a pretty slow process. But within about a week, I'd had something that felt like it was starting to look like a game. So I've got a little video here. I hope it's not going to be too laggy, but here's the very first version. This time we prioritized animations because I was really missing them in the previous version of the game. So I thought, I'm going to build this first, even before we had terrain, because why do you need terrain if you've got a running animation, you know? Interestingly, the running animation was actually specified in code with sine waves and things like that, which sounds a bit insane. It sounds completely crazy to do things in code like that. And my assumption was that we'd very, very quickly need to go for some sort of Blender approach where we imported animation data into the engine. And interestingly, that still hasn't happened. We've actually found that we've been able to get along with this way of doing things in a more procedural way by defining animations in code really quite well. And it's not actually been as hard to manage as I imagined it would have been. The other thing is that we tried to modularize things a lot more. So we split things up into the front end, which renders everything onto the screen, and then the core of the game client, and then also the game server. And then there's common code that sits between all of them. So for example, the client and the server both share the same physics code. They said that they share the same code relating to how entities will update over time and things like that. And this code sharing means that writing code in Veloren is quite easy. It feels like you're writing code for a single player game. You extremely rarely ever need to consider the implications of networking, which is really useful. So this was the first screenshot really of us actually implementing terrain into the new engine. So we came out on the second release, which was 0.2. The main character was modeled after one of our artists, one of the core devs. He's got a beard. I'm not sure if he's still got a beard. He may or may not. But that looks a little like him. It was very simple, really. I think you can maybe just barely call it a game, if that. More of a tech demo, really. It was more of a walking simulator, but it did have a large world that you could run around in. There was a command to spawn a pet pig, and the pet pig would run after you. When you walked into a wall, it still jumped you to the top of the wall, but that's fine, all in good time. At least we'd started to solve problems. And although it was very simple on the outside, the core of the engine was beginning to emerge, and I was really happy that we managed to get to a place where the fundamentals of the architecture were broadly correct, and the design that we had, even in 0.2, has not remained unchanged, but the broad strokes of it are the same. We've introduced more parallelism in various places. We've changed the systems that operate on data and exactly how they're structured, but the broad strokes are about the same. And a really big thing was that this change meant that the code base was extremely accessible now, at least compared to the previous one. No longer did you need to find your way through the rat's nest that was the code base. Instead, you could define a system in the code as like a simple function that took in data, made changes to that data, and then let go of the data and moved on to the next one. So I'm going to skip through the releases now because the next release is going to be 0.14. And there's quite a lot of releases between them, and about three years worth of work, which is not easy to summarize. But instead, I'm gonna talk about some of the really large things that were added. So one of our contributors basically came along in the first few months after 0.2, I think. It might have been a bit later than that, and basically decided that he was going to go away for 3 or 4 months and do as much research into the science of hydraulic erosion simulation as he possibly could. And this is the sort of thing that's only really possible in hobby software. You don't see this in AAA games because it's not economic to give someone that's got a PhD 4 months to go away and work out how to simulate erosion. But he did regardless, and the results are extremely impressive. So all of this terrain is entirely procedural, it's not been hand-authored. It just emerges out of the procedural rules that come with trying to simulate all of the erosion that comes with rain and rivers and lakes and so on. And the results are impressive at a distance, and they're also really impressive up close as well. You can see a stream here that goes down a mountain with waterfalls and so on. Another big thing we worked on was improving the world generation. So we added towns. They're quite fun. There's still not all that much to do with them, but they're growing and getting better. So there are merchants in them now that you can visit and so on. So there's actually some value in going to a town. There are crafting stations and things like that, so you can build yourself some armor. And we've also added caves and dungeons, various things. You can see here's quite a nice shot of a mushroom cave. They're quite fun to explore. Graphics was a very, very big change. If we go back to this slide, we can see the graphics are kind of lacking, to say the least. There's a little bit of baked ambient occlusion going on here, but the rest is pretty much just it's kind of a rendering model out of the 1970s, if that, to be honest. So there have been a lot of changes in this area. We've got dynamic shadow mapping now. We've got raycasted clouds that you can see here and a bit up here. So clouds are actually 3D, and we trace a ray through the clouds in order to determine how they obscure things in the scene. We've got bloom, which was implemented by the contributor that's on this call, actually, which is really, really nice. You can see a bit of it here in the caves. It makes things glow. We've got a dynamically changing sky, so you have day and night cycles and so on. We've got weather and rain and reflections as well now, and particles as well. So the game, in terms of rendering, is really starting to look a lot more like a AAA game in terms of the rendering effects, rather than simply a hobby project, which is really interesting to see, to be honest. We've also grown a lot of NPCs. We started off with just a pig, and we've now got, I think we're up to multiple hundreds of kinds of NPC and animal now. We've also got enemies and bosses and so on. So there's lots and lots to explore in the world, and the artists that have joined us in working on these have done an amazing job. I think something like 70 or 80% of the animals are done by a single person. One of our contributors who's just absolutely amazing at creating them. And then they've been all animated by someone else and so on. I'm always amazed as I enter the world and I see that there are like 5 new animals compared to the last time I joined. So how does it look today? So we've come quite a way. It's rather a large project now. The last release party, so we have a release every 3 to 4 months. And during the last party, we had 277 players on the server at the same time, which, quite frankly, is absolutely mad. I never thought that many people could possibly fit on the server, and yet it managed to cope. It coped fairly admirably, to be honest. And those players are all in like the same space, so they can all go to the same town, for example, and you just have hundreds of people that are walking around the same town. And the server, I'm sure, is off in Germany, absolutely screaming its heart out with all of the work it's doing in order to cope. We've recently gained a rather large Spanish community, so we got fairly popular on Spanish YouTube, and this actually forced us, it forced our hand a bit, and we had to build a server browser that would allow other third-party servers to be more visible and easier to connect to, which meant that we could start to spread the player base amongst multiple servers, because there's a point at which you just can't deal with this many people on a single server. So the next release is going to have greater emphasis on simulation and so on, and also musical instruments, which is going to be a joy to see, I'm sure. So just talking about the community for a moment, it's a bit hard to quantify, obviously. We don't have a single sign-up page to become a member of the community. We have various ways to think about the community in terms of how many people are in various spaces and have downloaded the game and so on. We've got 20,000 people on the Discord, which is an absolutely insane number. Quite a lot of people on other platforms. I checked the Git repository last night and got over 400 individual contributors to the code base now. And this one is more of a guesstimate, but I think about 1,000 total contributors if you include people doing art and music and so on. Obviously, quite a lot of that is a long tail, maybe only 10 to 20% of that are people that are very regular contributors or have done a substantial amount of work. Quite a lot of people have just, they've added a typo fix or they fixed a single bug or something like that. But we're starting to get quite popular in the Linux gaming community and other open source spaces. It's a bit weird to browse those kind of places and see Veloren mentioned. It's very strange, and we're kind of a bit of a flagship for game development in Rust now. I'm not sure whether we're still the largest Rust game. I'm sure there are larger ones in private being developed by companies, but we're the largest one that's public and open source by quite a substantial margin. So we often get pointed at when people are talking about Rust. I know that I had a conversation with who was it? The developer of Braid. I completely forgotten his name now. It's not so great.
Jonathan Blow.
Yes, Blow. Yeah, I had a conversation with him, and he's got some interesting opinions about Rust. He sort of tried to make the claim that you couldn't possibly scale up Rust to this kind of scale. It's too strict about how you can move data around and so on. And I pointed out that we'd managed to create this game, and we'd done it all with basically no unsafe code, and that kind of put that to bed a bit. So it's nice to be something that people can point to if you want to see what Rust can really do. It's quite a large project in Globe and growing. So now I'm going to dive into the internals a bit. How am I doing on time? Hopefully not too bad. I think I'm getting close, aren't I? I'm going to have to be faster here. So in terms of stuff we learned while working on the project, well, firstly, Rust is brilliant. It was a gamble as we started, but it's really paid off. The type system and the safety guarantees are absolutely brilliant, and it makes working with Rust a joy because the compiler has got your back. It understands your code. in a really fundamental way, in a way that other languages don't. And it can catch your errors, it can catch your mistakes. It makes scaling things up to larger code bases a lot easier, because the compiler will make sure you don't do anything too bad. Collaborating and review is a lot easier because the language is safe by default. You can audit a pull request, and it's extremely easy to go, okay, yeah, there's no unsafe in here, and this probably looks like it's doing what I think it's doing. And if it compiles and it looks like it's doing what it thinks it's doing, there's a much better chance that it actually is behaving compared to other languages. It's not a flawless process. Rust can't catch logic bugs, of course, and we still get bugs. But you don't need to be quite as versed in the code base in order to review things. Cargo and Rust Up are just brilliant. It makes the game extremely portable. It's really easy to get it up and running very quickly. And it's quite a large code base now. It's getting towards 250,000 lines of code. And we've got, I think, like three or four instances of unsafe. Obviously, that's not taking into account the fact that we're using third-party libraries, but those are often libraries that have quite a large user base, and so are more likely to be reasonably well audited. A few negatives, we still rely on nightly Rust, but I'm hoping that's going to be changing soon. Second is that game development is hard, but extremely rewarding. I mentioned at the beginning that I thought it was going to be an easy project. It wasn't. Turns out that trying to balance things and trying to tweak things and trying to make things work exactly as you want them to is really time-consuming and really hard. And I do not envy other game developers that are trying to get this sort of stuff working in larger AAA games. You can still write games without an engine. Rumors of the death of engineless development are overblown. It's fair to say it just takes a bit more time, but ultimately you do get a lot more control over the end result. A really good thing is to invest in tooling so that more people can join you in working on things. We have quite a lot of contributors that aren't too versed in Rust and code in general, and so they can contribute by editing configuration files. Things like, I think almost all of the items in the game are configurable now through text files and things like that. And also it's really good to be able to get really rapid feedback from players about things, but it's important not to listen to them too much. It's quite common that players will try to report an issue and will go, okay, this is definitely an issue, you're right, but what are the root causes of this? And often it'll be that the issue is more of a balancing issue, or we need to rework another system rather than just adding something like fast travel in, which is a superficial fix, but I think the game loses a lot by adding a quick and easy solution like that. Program things kind of defensively. Quite a common thing for people to do is, because we try to avoid adding invisible walls into the game, so sort of arbitrary limitations to what you can do, quite a common thing is for players to actually pull a boss all the way out of a dungeon and into the nearest town and things like that, and all chaos ensues as like the entire town is battling this boss. So that's a thing that can happen quite often, and it used to be the case that players would pull them into the spawn town and kill new players. So we had to work our way around that. Arguments are definitely a thing that will occur because it's a large community and everyone disagrees about the forward progress. But the way around that, I found, is just to implement something and see whether people like it. If they like it, then you keep it, and if not, you change it later. It's much easier to lean into things and iterate quickly. So talking a bit more about Rust, you want to parallelize things to make things fast. We're in an era now where Moore's law is beginning to lose a bit of its steam, or quite a lot of its steam. and you need to parallelize things in order to make them faster. So they're running on multiple threads. And the great thing about Rust is that it makes all of this stuff really explicit. So you control when you want to mutate something. You can control whether a certain piece of data is safe to share across threads and so on. And Rust allows you to be really fine-grained about exactly how you do this. It's really important to try to rethink the problem quite often. We found that this is an approach that works for quite a lot of the systems in our game, where you start off with the original game state, you split the work to be done by a system up so that it can be fed to multiple threads that are running as workers. Almost all of the time, there will be no changes in state that are required, but occasionally from time to time, there will be a change in state that's required. So rather than putting a lock around the entirety of the game state, it's instead better to write those changes that need to be made to a small cache, which does have a lock out of it, a lock around it, and then later on you write the changes back when you're back in the main thread, effectively. And this means that you're not pessimizing the average case where you just want to access something immutably and never mutate it. Excuse me. The disadvantage, of course, it means that you've got to wait until the end of the system for your changes to propagate through. So understanding when you can apply this sort of pattern and when you can disconnect all of the points of synchronization in your code is really important. The next thing is that Veloren is running at a lot of scale now. It's running on a 48-core machine on the official server. And when you get to something of that sort of size, a very small number of things start to dominate all processing power, for example. So virtually all of the systems take almost no processing power, and almost all the processing power is taken up by, for example, the collisions system, because the complexity of the problem is O(n) squared. For example, if you're trying to detect a collision between n entities and n other entities, you end up with n squared calculations. And doubling the number of cores only actually doubles your performance in your imagination, because you have all of these n squared problems and various other worse than linear problems that tend to appear as you scale things up. And it means you end up with a lot of bottlenecks that you've got to solve. And there are strategies to work around it. I mentioned one that's quite effective here. We also have things like spatial partitioning, where we split the entire world into grids effectively, and every entity registers itself with a grid cell. And then when you want to detect a collision, you only look through the cells that are neighboring your current cell in order to detect a collision. And that means that you can have loads and loads of entities in different parts of the world, and it'll be closer to an O(n) problem, but it doesn't solve it in general. You still get points of interest like towns where people tend to congregate, and then you just end up with lots and lots of entities in a single grid cell. And so you still go back to this O(n) squared problem. It's quite hard to avoid in the general case. Last thing is that perfect is the enemy of good. It's quite common if you're working on a solo project to try to make things really perfect. But we found that you've got to accept that chaos is part of the process, and things can always be refactored later. It doesn't have to be perfect the first time it merges. You've got to accept that things can be iterated over. And part of that is that the code base will go through change. So trying to over-engineer things, trying to design things in such a way that they're always going to work forever over many, many changes to the code base is usually not a good approach. It's actually a lot easier to refactor a system that's very small and simple once you know the way in which it needs to be refactored than it is to build a system that's incredibly large and expansive, but ultimately fails to do the thing you want and needs to be refactored later, except now it's really hard to refactor because it's very big and complicated. And I thought this quote from Albert Einstein is quite apt. any fool can make things larger and more complex. It takes courage and genius to go the other way. And by the same token, the best way to avoid that is to just keep things really simple in the first place. To never make them large and complicated unless you really need to. Thank you for listening. That's broadly it. I hope you didn't go too long over time. You can join the community or download the game. It's quite fun to play. I guess we're at questions now.
Thanks, Josh. That was brilliant. It was really good, and I actually learned a lot. I have some notes. I have some questions, but first, maybe anyone else has questions. So I'll try to take questions from the room and the chat, so we don't have issues. So any question from the room for Josh? Okay.
I will say one thing. Great talk, by the way. I've been in the video game industry for over 25 years, and I can say that a lot of what you put on your slides is really good advice. So anyone new in the industry or new wants to get into it, really study those slides. So really great advice in those. I'm pretty impressed you came to those conclusions as quickly as you did.
Well,
so soon after university.
I mean, it took quite a few years to get there, but it was very much a case of bashing our heads against the wall until we realize, this way offers a little less resistance. And I think one of the really great things about Rust is that it forces you to come to terms with your bad ideas a lot faster than other languages do.
That's true. I think I deleted around 100,000 lines of codes of bad, like over-engineered systems, replace them with like something like 10K lines of code. It just works as well.
There's nothing better in video game programming than deleting code.
Yeah,
I think it's true in any industry or whatsoever.
What is programming if not the act of adding bytes to an empty text file?
Yeah. I've got a question. That first I start like question on the game is doors. So I played the game, and doors are bad. It's like you can just go through them, you can open them.
There is a Vox video that I think is worth watching. That's purely dedicated to why doors are difficult in video games. They are infamously hard to get working right, and I've wanted doors that actually work for a while, and the pieces are sort of getting towards being there, but there are a few issues like how we animate a static sprite and things like that, because the doors are actually blocks and we have storage limitations and stuff like that. I mean, it's quite hard to tie data to them, but we'll get there eventually, or someone will come along and decide, okay, you need doors that actually open now.
Yeah, it's quite funny that you got water erosion right. That's great. Which leads me to my second.
Like, one of the things that come with it not being a AAA project and it being like a contributor-driven thing is that there's a weird inversion of priorities in a lot of ways. There are a lot of things that are extremely janky and odd, and a lot of things are way too detailed. But that's just part of the terrain, I think.
And so how do you manage all those people contributing? So 400 contributors, thousands of people discussing.
Quite often we don't. I would say that there's probably like a core of maybe 40 to 50 people that actively engage with the game and the process of development and feedback and so on, and play testing and working on it. As core contributors, there are maybe like 15 to 20 of us. We spend a lot of our time reviewing code and pull requests and so on, but quite often we sort of let people get on with making the changes they want to make, unless they're particularly controversial. If things are controversial, that usually goes to like a discussion process, but usually the scope of the game is so open-ended and so large that there's rarely controversy. The answer is always, yes, why not add that? You know?
Yep. Like maybe one day someone will come with a solution for the doors. Very nice. I've got other questions that maybe a bit more technical. So in terms of, unless someone else has a question first, in the chat or in the room.
We've had a few in the chat. I think they've mostly been covered by, apologies if I pronounced his name wrong, but I think they've been covered by Swastik. But I think there was another one. Yes, have Microsoft or Mojang been in touch?
Okay, so no, but a few of us have managed to land jobs as a result. So the code is released under GPL3, which, as you may or may not know, is quite an aggressive open source license. It requires that any derivative code also has the same license and has publicly available source code, which I think is not always a good choice for all software. If you have something like a library, you probably want that to be linked in to a larger piece of software without inheriting those kind of terms. But for an end product like our game, I think it's quite a good license because it keeps the community together. You know, it's very difficult to make a fork that just goes off and does like an assets strip of the game and then sells it. But also, all of the code is licensed under every user that actually developed it, which means that there are 400 to 500 odd people we'd need to ask in order to relicense the game as anything other than open source. So I think it being free and open source and community driven is basically baked into the code at this point. You know, it's not going to change even if we wanted it to, which we don't.
I was going to ask if this project inspired anyone else.
Yeah, we've seen a few other. Yeah, apparently the audio is extremely good there. But we've seen a few other people that have sort of got involved in making their own games and have entered the community to ask some questions about our approach, things like that. I know I've had some contact with 2 or 3 other developers that are working on their own little projects. They're usually voxel engines. So yeah, it's been really nice to share the knowledge we have and pass it on, and also pass on all of the things we found as a result of actually building the game. You know, I think there are quite a few things that are genuinely unique to Veloren. So the way we store terrain data, for example, is extremely unique, and it allows us to have mountains that are literally multiple kilometers high and things like that.
Got another question in the chat, Fake Out. How does GPL3 work with third-party crate contributions?
So we can take crates which are more permissive than GPL3 and include them, or we can take crates that are GPL3. So it's specifically with regard to people can't take our code and use that without auto-releasing under GPL3. One point where that may start to become a bit of an iffy issue is that the code base is extremely modular, so you can build an entirely different graphical front end for the game. And in fact, there are a few other alternatives. There's a command line front end, for example. So you can use that by just using the core client library and then just building a UI on top of that. So I think that might become a bit of a factor to consider in the future when people start to build more things on top of them. But so far, it's not been an issue, really.
Any other question from the room? Right. I've got one last question. Oh, actually, I had 2, but I'm going to ask only one. I saw RTX on, like as a small load corner of an image.
That was That was a meme. It's actually only screen space reflections and so on. It'd be nice to get hardware accelerated ray tracing at some point, but it's not really a priority at this point.
Yeah,
And also, it turns out that you can make things look really good without it.
I don't know. Nice. Is there any other questions from the online?
Hello.
Hello.
I think the project uses WebGL, right? As a rendering graphics library.
So we use WGPU, which is
Oh yeah, WGPU, right?
Yeah,
Is there any
it's-
thought about it?
from what I've seen, it's really, really good. You know, I've worked with it on a few projects now, and I've never found any limitations or issues that are fundamental. It's a very fast library. It's very easy to work with. It really gets the right point of abstraction between giving you loads of control and being really difficult to use. It's kind of right in the middle. So it's sort of kind of equivalent in complexity to OpenGL, except without all of the problems that are pervasive to OpenGL.
Are you planning to replace GLSL code with the newer shader code that is like using Rust syntax in some sense?
Yeah, so WGSL is, I assume, what you're talking about.
Yeah, I guess so.
That's an option in the future. So far, I've not seen any WGSL compilers that have impressed me enough that I'd want to make the switch. And I think there are enough problems with the language in terms of the standard that I personally wouldn't feel it's worth making the switch, especially given that there's maybe about 10,000 lines of GLSL. Yeah, GLSL to port over to WGSL. I think if we were going to go down that route, we'd probably look into the Rust GPU project and try to actually port the shaders to Rust itself. But there are quite a few complexities associated with that, like hot reloading, which we'd need to figure out first.
Which area in the game do you think you need more like contributors in terms of workforce, like just normal contributors?
I think all over, but one particular focus now is the simulation aspects of the game. So obviously we're inspired by Dwarf Fortress quite a lot, and Dwarf Fortress is infamously basically a procedural story generator. And that, I think, is going to be an increasing focus for the project as more and more of the peripheral stuff gets resolved and polished up. And there are maybe only 3 or 4 people really actively working on world generation and simulation at the moment. So I'd love to see new contributors that are interested in learning about procedural generation or working on the project to join and take part in that. I would say I'm probably biased because that's the area I mostly work on, but still.
Is there any video guides about how to start contributing to the project?
Yeah.
Or one that is like a wiki in some sense, like I guess it's a website.
Yeah, so we have a book, sort of like the Rust book, I guess, but for Veloren, and it's got kind of an introduction guide for both players and contributors. If you go to our YouTube channel, we have recorded code reading clubs that are usually about an hour long each, where they focus on a particular area of the code base and they explain what's going on. They quite often they implement a new feature within that part of the code base. I did one on the world generation code and how you can generate new buildings and things like that.
All right, thank you.
Okay.
Excuse me.
Thank you, Josh. I think we move on to the next talk now.
Okay.
It's going to be Felix. I'll try to change the setup as well so that you can see the room, but from the laptop. And also Felix doesn't have slides, so it's going to be a bit easier. So a quick intro. So Felix, I think he attended the meetup once. He became a Rust developer recently.
Yeah,
very recently. And I think a common topic of